We're going to be looking at finding a point of a coordinate using the distance formula. So here's our question. We'll read through it and then I'll try to make sense of it. A line segment, okay, it needs to be a line segment because it needs to have a starting and ending point to actually have a distance to it. Otherwise, lines are essentially infinite. A line segment has a distance of 25. Okay, one of the endpoints of the coordinate is -3, 8. The other endpoint has a coordinate of the x value being unknown, but a y value of -9. Find the missing x value. So I'm kind of graphed it out here. Here's one of our endpoints at -3, 8. And the other x value is unknown, but we know the y value is here across the y. We just don't know where. Now, I'm going to touch on an idea here. We don't know where it is. And let's see if I can come across and do this. Oops. That should help a little. Okay, so we don't know where it is. And let's just say I'm drawing something that's 25. We also don't know what direction it is. So maybe it's to here, or maybe it's to here, which means we're going to have two sets of answers in this question. Okay, and I'll show you algebraically what that would look like. Okay, I'm going to put this back on the other page. Okay, so here's our information. I'm going to turn off that other thing. Okay, so here's our information, and here's our distance formula. We're going to use this formula to figure out. We know our first coordinate is at -3, 8. So I can either call that coordinate 1, coordinate 1, sorry about that, or coordinate 2. So we have, let's just call this point 1. Okay, so this will be our x1 and our y1. So we're going to plug those values in for x1 and y1 in our formula. So our x1, here's our y1. We also know the distance being the value of 25, so we're going to replace the value of d with that. So algebraically, we'll have 25 is equal to, okay, we still have our square root. Our x2 is an unknown value. Right? And actually, I should highlight that part too. Our x2 is unknown. Right? We're going to call that x. But our y2 isn't. That's actually going to be the value of -9. So we are going to plug a value in for that. So our x2 is unknown. Subtract our x1 was -3. So we're going to subtract -3. And all of this is squared. Plus y2, which is our -9. Subtract our other y value, which was 8. Squared. Okay. So now we're going to work on simplifying some stuff underneath the brackets before we start isolating. Okay, we still have 25 is equal to, and again, we have our wonderful square root here. Now I have x2 minus -3, which can be simplified to say, and I'm just going to write it as x from now on. Our two negatives, you can kind of look at it as looking like x plus 3 squared. Okay, and that'll help us out a bit. Plus, underneath the brackets, -9 and -18 is going to be -17. So -17 squared. Okay. Now I have this big square root, and I kind of want to get rid of it. So one way we can do that is by squaring, okay? So this is kind of simple on a computer. I'm going to square both sides of the equation, okay? When I do that, that's going to eliminate the square root on this side, and our 25 is going to grow by multiplying by 25. So let's figure out what that value would be. 25 squared is 625. So on the left side, we get 625 is equal to, and the square root on this side disappears. So we have x plus 3 squared plus, and we need to figure out what -17 squared is. Well, we already know that a negative times a negative is going to be a positive. So I can really just write 17 squared, and it's the identical as -17 squared. We get 289. So plus 289. We still want to isolate for the x on this side. Okay. So in order to do that, I'm going to move 289 to the other side, and we'll be subtracting by it. So 625 subtract 289 will be equal to our x plus 3, we're getting closer now, squared. We'll take a look at what that is. 625 subtract 289 equals 336. So we get 336 is equal to our x plus 3 squared. Okay, so this is where algebraically we start to get two answers. We want to get rid of this squared, and we'll do the opposite of what we did up here to get rid of the root. We're going to actually square root, hey, I did that pretty well, both sides of the equation. When we do it on the right side, the square root and the squared will eliminate each other, essentially creating a power of 1, which doesn't change our base. And we have x plus 3. And we don't even really need the brackets anymore for that. So we'll just write it as x plus 3. But on the left side, the square root of 336, so the square root of 336, and I don't know if the calculator will write that in. Okay, so roughly 18.33. Now, the problem here is it's actually plus or minus 18.33, right? Because negative 18.33 squared or positive 18.33 squared will still be positive 336. So we're going to end up with two answers. So the algebra splits here. Okay. So we get positive 18.33 equals x plus 3, and we also get negative 18.33 equals x plus 3. If you remember at the beginning of the video, we talked about how we'd probably get two answers because we don't know if the line is kind of going in the left or right direction. When we bring 3 over, we'll be subtracting by it, so this will end up being 15.33 is equal to x. And this one will actually be negative 21.33 is equal to x. So we now have two coordinates. One of the coordinates reads 15.33, that's the x value, and what was the y value? Negative 9. Okay, that's our y. Or negative 21.33 and negative 9. And these are x and y. So let's kind of take a look at what that looks like, 15.33. So one of them is 15.33 and negative 9. Okay, can we see that here? Yeah, we can. Here's our coordinate, and essentially that's a distance of 25. And our other one says negative 21.33 and negative 9. And there's our other coordinate. I know we're eyeballing it, but the idea is essentially that these two coordinates are both the distance of 25. So either of these answers is correct. Maybe a question we specify, give us the positive value or give us the negative value, but you get two answers regardless in this question.